This class represents a binary logistic regression model. The constructor initialized the model with a rich regularization coefficient lambda, weight matrix, and bias. It takes an optional parameter lambda representing the rich regularization coefficient. The default value is this. And then mu method. This method applies the sigmoid function used in the logistic regression model and calculates the probability for each observation. X matrix containing observations. Each row represents one observation, and Y vector containing target values. This contains the correct class label of each observation. Z calculates the term inside the sigmoid function. Using the Z term, it calculates the probability of each observation via the sigmoid function. The sigmoid function converts the input value Z to a value between 0 and 1, and then loss function. This function is used to calculate the loss function of the binary logistic regression model. The purpose of this function is to calculate a loss function that controls both the data loss and the magnitudes of the weights to increase the accuracy of the model. This is generally interpreted as the mean error. This performs a matrix multiplication on the model's weights. It represents the sum of squares of the weights. Multiplying this by self lambda, we regulate the weights, and we add the mean error and this. Overall loss value is obtained, and then this function calculates the gradient of the loss associated with the weights of the binary logistic regression model. This expression computes the gradient vector and returns it. This gradient vector is used to update the model's weights. Bias, gradient G bias. This function calculates the gradient of the loss function J with respect to bias. During training of the binary logistic regression model, this gradient is used to update the bias parameter using the gradient descent algorithm. This line calls the previous function mu to compute the mu value and assigns it to the variable mu. This line assigns the size of the target vector y to the variable n. This value represents the number of observations. This expression calculates the dot product of the mu and y vectors. This expression calculates the sum of the elements of the y vector. By taking the difference of these expressions, it computes a part of the gradient for the bias. and overall this expression divides the bias gradient by n, the number of observations to obtain the final gradient value. This function computes the gradient of the loss function with respect to bias variable for the given observations and targets. And predict. This function is one of the key features of the binary logistic regression model and makes class predictions for input samples using the model's learned trained parameters. This step represents the relationship between trained parameters of the model and the input samples. The NP sign function assigns -1 to values less than 0, 0 to values equal to 0, and 1 to values greater than 0. In this case, the model uses classes -1 and 1. Misclassification error. This function calculates the misclassification rate that a binary logistic regression model makes on given observations. The main purpose of the function is to evaluate the performance of the model on given observations and calculate the misclassification rate. The misclassification rate is an important metric to understand how effective the model is. This expression creates a Boolean array indicating whether the correct prediction occurred for each observation. Returns the total number of incorrectly predicted observations, divides the total number of incorrectly predicted observations by the total number of observations. This gives the misclassification rate. And step method. The step method represents a single step in a training cycle. This step is used to update the weights and bias of the model. And train. The train method represents a learning algorithm that trains a classification model using mini-batch gradient descent over a specified number of epochs. It updates the model at each batch iteration and records the loss values and error rates on both the training and test sets at the end of each epoch. The method returns a dictionary containing these values for analysis and evaluation. This line history model trains the model with the specified parameters, and the loss values and error rates recorded at the end of each epoch are stored in a dictionary called history. It then pilots the loss and error rates for both the training and test sets. The same operations are repeated, but this time batch is 1. Here is 100, batch size 100. As I wrote to you on Teams, I get a multiple lib error, so I asked a friend to run the code, and he sent me screenshots of the outputs. I will show them now. This is the loss graph of B. Misclassification graph of B. This is loss graph of C. Batch size 1. And misclassification graph for C. And loss graph for D, batch size 100, and finally misclassification graph for D.